Hi, this is a quick attempt at looking at question 3 and 4 in the last exam paper 2, which is the practical one. And as you see here, stuff like bringing a ruler, having a calculator, know how to do graphs and how to do tables are really important in paper 2. Again, I do apologize for the low quality of the drawing and the bad use of paint, but this is what I have right now. Okay, so here in question 3, we start with the MARPOL rules. And MARPOL rules are the rules to avoid pollution from tankers. And they ask you to give 2 MARPOL standards that reduce the risk of marine pollution. And there's several you can choose. But I have chosen like double hulls, so there's less chance of a leak from a wreck or accident. And ships are under agreement not to wash out the holes except at special collection sites. You can also talk about sewage release from all ships and garbage disposal. But since this is a question here about oil, I choose the 2 that are most related to oil. The rest will be correct as well. So here we are asked to describe a simple laboratory-based experiment to investigate the effect of pH of adding carbon dioxide to seawater. And here, again, it's important to be specific. I had quite a few students who just said, add CO2 to water and see what happens. And while this is not wrong, it's also not specific enough. So here is how I would do it. I'll say, first put seawater into a boiling tube. Let's be specific. We're looking at seawater. Put a pH sensor or universal pH indicator in. Choose one of them and record the pH. Then you can bubble CO2 into the water from a tank. You can also write, you can just blow into a straw, else there'll be CO2 in the air, you expire. After a set time, record the new pH, and then come the important part, compare the 2 values of pH and calculate the change. This way you are specific and it's laboratory based and you're sure to get all the points. So next we are giving a quite long description of an experiment where you look at the difference between water level of over here our sea ice, and here we have our land based ice, and we're giving the method here, and this can seem confusing. What are they asking about? But again, it's important to read through everything here, like how they're using the same numbers of ice cube, they're having the same amount of water, but here the ice is floating, and up here the ice is elevated and is hanging in a sieve. And then we are here showing the students results as they might look, on their notebook. All this we're going to use later. So please take note here that there's no question on this page. There's just a lot of information you need for the later questions, but all the information is here for a reason. The next one here is one we also often see in marine science, where you're basically asked to draw a result table. And this is super simple, and yet I see quite a few people who don't get all the points here. Basically, right, we have our time in minutes here, and our height of A in millimeters, of height of B in millimeters. Important thing is we have the units up here. So here I can only write like 0, 2, 4, 6, 8, and my 10 minutes. And then here, again, the unit is up here, so I don't have to write the unit in the table. It's 62, 62, 62, all the way down here for our seaborne ice. And for our land-based ice here, we see it different. We're starting at 50, 52, 55, 58, 59, and 60. So this is a way to get the points, and this is another reason why you should always, bring a ruler. Because that makes making a good and attractive looking table that much easier. I mean, this is an easy way to get 4 points. Just remember we need to have the units in the headers, and we need to use increasing time, and we use a ruler, and we put in our numbers. So then we asked to discuss how the results show that melting of land-based ice poses a greater threat compared to the melting of floating ice. And I had quite a few students who say that land-based ice leads to more flooding. And while this is correct, if we want to get all the points, again, we need to be specific. So here's how I would do it. I would make clear that melting of seaborne ice, as we see in A, does not increase water level, but melting of land-based ice, as we see in B, does increase water levels. So melting of land-based ice will lead to higher risks of flooding and potential habitat loss in coastal communities. This should get the 3 points, but just to make sure, I also write that a large influx of fresh water can also change ocean currents as the Gulf Stream. Now we should be pretty sure that we have all 3 points. And as always, whenever Cambridge have done one of these, describe an experiment, they'll always end with this question here: describe some ways that the student could improve the experiment. You're only asking for 2, but I've chosen to give a few more. I'll say you could use the same volume of ice in both setups. We're only told it's the same number of ice cubes. We don't know if it's the same volume. And then the golden one, repeat the experiment at least 3 times. That's an easy one always to use here. Also, you can say you can control and record the temperature in the room where the experiment is conducted. You can also talk about using a more narrow beaker to have a bigger increase in height as the ice melts. And lastly, we only let the experiment run for 10 minutes. They can let the experiment run for a longer time. Just 2 of these should be enough, but I'll say always use the one where about repeat the experiment at least 3 times. The next question here also is in chapter 6, where we go into marine protected areas. There's a lot of focus on that here. And marine protected areas are areas where there's no fishing. And again, scientists investigate the effect of setting up MPAs in the area of Indian Ocean. And we look at 2 different ones here. One where it's a marine protected area, and one where the area is actually fished. And this sampling was done between 2013 and 2017. And the number of different species of fish in each were recorded. And then we have here, down here, our result table. All this we're going to need for the next question again. So here we have, again, an entire page of text without a question. Please pay attention to everything here, because it's going to be very handy when we answer the question. So now they ask you to use the table 4.1 to plot a graph with 2 lines to show the number of different species of fish in the coral reef in the MPA. And join your points with rule straight lines. Another reason why you should always remember a ruler. And I'm just going to show you the setup here again. Very badly done in paint, but please notice I started by labeling the axis. We have number of different species, years, and I put in my units, years on my x-axis, numbers of different species on my y-axis, and also my y-axis take up more than half the space. If it doesn't, I'll get a point less. So just by doing this, I have already gotten some of the points. Again, I do apologize for my bad skills in paint here. Now I've plotted in my points, and I try to do them with small crosses. Again, this could be done way more accurate if I didn't do it in paint, but I hope you get the point. And then come the important thing. I have to then join them by ruled straight lines, which means again I need this here to bring a ruler to be able to do this. So this shows my marine protected area. I need to label them so it's clear that this is marine protected area. And this here then is our normally fished area. And again, please be accurate here. Be more accurate than me. And here, but just by doing that, we just gotten 5 points without actually knowing anything about the science. Just by able to draw a graph, a table, plot a graph here and use a table, we can get 5 points. This is going to be there every year. Practice how to draw a graph. And then we are asked to suggest 2 abiotic factors that the scientists should ensure are the same when comparing the coral reef areas in the MPAs and the coral areas in the actually fished areas. They just ask for 2. It's important, it's abiotic factors. And here we need to go in to think about what are the issues, what are the things we can't control, because this is not done in the lab, this is done out in the ocean. And there are quite many. Well, we need to look at, for example, we know corals are affected by salinity. We can also look at wave speed and currents. Temperature. Temperature is quite important for corals. We can also look at, should we look at minerals, nutrients, pH, oxygen concentration? Are the corals at the same depth? Do we have the same water clarity? And do we have the same area of coral reef sampled? It matters a lot if we sample like 2 square feet or we sample 1,000 square meters. So just choosing a few of these here, and remember it's abiotic factors. So then we look at sampling of the density of coral polyps, and we're giving a result table here that shows that there are more the density of corals are higher per square meter in the marine protected areas than they are in the actively fished areas. But the question is here, describe a method to measure the density of coral polyps in these areas. And here in your book, you have to go back to section 5.2 in the practical task 5.1 and 5.2, which actually shows how to do it. And my answer would look something like this. I'll use a method where we sample quadrants, and then I'll set up a grid system that can be used without damaging the coral reef, so I can't put anything on the corals. Then I have to choose random currents because we're told they're doing random sampling. Then I count the number of polyps in each chosen quadrant. I repeat at other sites, and then I calculate the mean percentage coverage of quadrants, and then I can go in and find the density of coral polyps per square meter. So now we finally get to use our numbers, and that's great. So we're told here that we have to use table 4.2 to calculate the percentage density decrease in density of coral polyps in the active fished area. Okay, so we know here that we start with 144, that's our start number, and then we subtract 102, that should give us a difference. But if we want to calculate in percentage decrease, then I have to divide by the number I start with, 144. Then I have a decimal, but I want a percentage, so I multiply by 100, which gives me a percentage of 29. Again, remember the calculation, because as they ask here, show your working. So we get to the explain part. Explain the effect of increased density of coral polyps on the change of the number of fish species in the MPA between 13 and 17. And we have to use the data in both table 4.1 and 4.2. So there's a lot to do in this question here. I would answer it like this. I'll start by saying that in the marine protected area, the number of corals increases, and so does the number of fish. Hence, I've now used the data in 4.1 and 4.2. Then I'll say that corals contain zooxanthellae and are primary producers, so there'll be more food available. Thereby mentioning that primary producers are important for the food chains. This will lead to more diverse food chains. Okay. More corals will also make a more diverse habitat where there are more hiding places to avoid predation, and there's more local niches for organisms to exploit. This should give you all 3 points. The last question is very, very specific, and they ask about the triggerfish. And if you open your book on page 254 on figure 5.63, you'll see a triggerfish. And this is one of those questions, either you remember it or you don't. It's only 2 points, but still, this shows why it is important to study every part of the syllabus if you want to make sure to get all the points. Because the triggerfish has spines on the dorsal fin that makes it really annoying if you try to eat it. And also, the spines are also useful for locking themselves into crevices on rocks so they can hide and are harder to eat.